Hello, comrades. This is a fascinating question from a Barker past paper. It's Extension 1, Semester 1 exam from 2012. And it's a graph to do that relies... It's a graphical question that's going to use two concepts, asymptotes and odd and even functions. So what I'm going to do is I'm going to read out the question, and then I'm going to explain these concepts about asymptotes and odd and even functions separately. And then as we go, I'm going to talk about how they relate to the question, and we're going to be able to cross out a few answers as we go using our knowledge as we go along. So the question is, we've got given this graph, and it says the sketch of a function, just some arbitrary function, y equals f of x, could have the equation of. So basically it's saying, here's a graph, you don't know its equation, which one of these could it reasonably be? So yeah, it can't be y equals x squared, because that's going to be some parabola like this, or it can't be y equals x, because it's a straight line. Which one of these is it kind of feasible that it might be? So what we're going to do is, the first concept we're going to talk about is asymptotes. And I find these really interesting, because what an asymptote is, kind of by definition, is, think about as x gets really, really small, this graph here is going to approach this y-axis, and it's always going to get closer to it as x gets closer to 0, but it's never going to get there, which philosophically is fascinating, because say, there's kind of like nothing in the real world I kind of think about that is like that. I mean, when you're going to school, it's not like you're getting closer and closer to school, but you're never going to be able to get there. From a philosophical standpoint, I think it's really interesting. But where this asymptotic phenomenon derives from is when you've got a graph like this, y equals 1 on x. So you can chuck x equals 0 in here, x equals 0, and you're going to get y equals 1 on 0. And the reason 1 on 0, well, 1 on 0 is undefined. And the reason it is undefined is because you're saying, how many times does 0 go into 1? And loads, you can chuck in 100,000 zeros, like adding them together, and you're not getting closer to 1. So it's not really a defined number. So you end up with this asymptotic phenomenon where as x gets smaller and smaller and closer to 0, it's going to get closer to it, but never there. And it's just it's not just on the y-axis. You can have asymptotes. I mean, if you've got the graph y equals 1 on x plus 1, when you chuck in x equals minus 1 into here, what you're going to get is minus 1 plus 1, so you're going to have a 0 on the bottom. And then what that'll do is, when you chuck in x equals minus 1, you'll have this similar asymptote just here. So, excuse me. So now what we're going to do is, we're going to think about how this asymptotic ideas that we've just had relates to this question. So you can see there's no asymptotes on this graph. I mean, no, there is obviously like horizontally, but vertically there's no vertical asymptotes. So we can rule out a few things. So this graph here, A, when you put in x equals 0, there'd be an asymptote. It would be undefined at x equals 0 for this option A. And there's something that's defined at x equals 0. You've got this point 0, 0, which is a defined point. So it can't be A, because it hasn't got an asymptote at x equals 0. D, a similar idea to what we had in this picture over here. When you put in x equals minus 1, so say about minus 1, you'd expect to have an asymptote here if this was the graph, but that's not the case. So we can rule out B and D. So now it's just a two-horse race between B and C. I feel like bloody Eddie Maguire. So odd and even functions. So we're going to use this concept now of odd and even functions to talk about whether it's B or C. So odd and even functions are really interesting, and I've just drawn a graph, even functions on the left and odd functions on the right. So we'll do evens first. Even functions, the easiest way to explain it is just that it's a mirror image over the y-axis. So I've drawn a few here. So y equals x squared is one, or y equals cos of x. Well, I've just drawn a limited domain of y equals cos of x. They're both even. And another way of thinking this algebraically, where you get this mirror image phenomenon, is when you put in plus x. So when you put f equals plus x, the y value you get back out again is the same y value as what you get when you put in minus x. So when you get minus x over here. So this expression here is the condition for an even function. And it just, but for graphically, what it means is that you've just got this reflection over the y-axis. Beautiful. So that's even functions. Odd functions are kind of the opposite. So you can have even functions, odd functions, or neither. We won't talk about neither for now. Well, it's just neither of these two cases. But odd functions is, say you've got the graph this is the classic odd function, y equals x cubed. So with even functions, what is on the left is the negative of what is on the right. So that's just the best way of thinking about an odd function. And the algebraic condition is when you put in plus x, the y value you get back is the negative of what you get when you put in minus x. So but just graphically, the way of thinking about it is what's on the left is the negative of what's on the right. So with that concept in mind, let's think about B and C here. So first of all, this graph is not even because it's not. If it was like this, and you kind of had these two mountains here, kind of like a bird, like a seagull in those really bad drawings, it would be an even function. But it's kind of what is on the left is the negative of what is on the right. So we know that this is an even function, an odd function, excuse me. So this is an odd function because what is on the left is the negative of what's on the right. So let's think about this. So when this here is an even function. Because when we put in minus x, so f of minus x, what we're going to get is we put in minus x on the top, and minus x squared is just x squared again. And then we put in minus x down here, minus x squared is just x squared again, because when you put a negative number and square it, you just get the positive number squared, plus 1. So f of minus x, you can say this is exactly the same as just what f of x is. So, so we get f of minus x equals f of x. And remember from down here, that was the condition for an even function. F of plus x equals f of minus x. So this is an even function, this one here. But the graph is an odd one. We've just talked about why it's an odd one. So see you later. So it's got to be B. And just to really nail it home, when you put in minus x into this graph, I'm talking about B now, you get minus x on top. And then you put minus x into x squared, and you just get x squared again, plus 1. So f of minus x is the same thing as minus f of x, because this is the negative of f of x. And remember from down here, that was the condition for an odd function. So we're nowhere in business. It's B, because there are no asymptotes. There's no vertical asymptotes, sorry, and it is an odd function. So that's all we're going to talk about for this one. Hope I was clear, and I'll see you in the next vid, children.